So you were wondering how to integrate when something was more complicated, something along the lines of perhaps, we have the reverse of the power rule. What about the reverse of product rule, quotient rule, chain rule, and things like that? So, yeah, I know. As I could read it on all of your faces. So we're going to look at the reverse of the chain rule called use substitution. I have the process written right here, and it's really actually pretty straightforward conceptually. You could get bogged down on different possibilities for designating your U value, which I'll get into in a minute. But really the big challenge going forward, bless you, the big challenge going forward isn't going to have to do with this individual topic or the individual topic that comes after that, or this and that and the other thing. It's going to come from not getting the different topics confused with one another. All right, so when we learn integration by parts, down the line you'll look at a question and say, how do I know this is integration by parts versus use substitution? All right, that's the key ingredient here. But this is the foundation of the rest of the year. All right, this one topic. Because it conceptually is embedded in everything else we do. That's how important it is. All right, so how do we do it? Well, what we do is we choose a U. So, and that U could be a function such as the inner function of a composite function. If it's exponential, it could be the exponent. If it's a log function, it could be contained it can be contained within the logarithm. Same thing with the trig function, sine of, let's say, x squared plus 1 or something like that. In this case, it looks like it's just the x squared plus 1. But generally what we're looking for is something that is differentiable to the other part of the function. All right, so choose a U such as the inner part of a composite function, but it must differentiate to be a scalar multiple of the other part. So the question would be, well, what do you mean by the other part? So the answer to that would be, well, the part that you didn't choose. So you're going to choose one part of your function to be U, to be the U function. Whatever the other part is, has to be a scalar multiple of the derivative of the part that you selected as U. Right? So it's only off by a constant multiple. So here we have a 2x. If I select this to be my U, its derivative has to be a scalar multiple of 2x, so maybe 4x or 10x or even x, but it has to include the x. If it doesn't, then you selected the wrong U. Right? In the early goings, everything is going to work out. Later on, we're going to have to manipulate algebraically or even trigonometrically to get it into a nicer form so that it does work out. But once you've selected your appropriate U, very easy. I'm going to let U equal x squared plus 1. Trial and errors, at least in the early goings, is not a bad strategy, because if you select the wrong U, you find out pretty quickly. And then you just, okay, well, that wasn't the right U. I'll choose the other thing then, and then start over. All right, so I select my U as x squared plus 1. I'm going to take the derivative of this, which is going to be du dx is equal to 2x. All right, so this differential equation, the du dx equals 2x, is going to help me make a substitution within my integral. All right, so first thing I'm going to do is replace the x squared plus 1 with the u. So this would become 2x times u dx. Now I have an inconsistency here with my variables. I can't integrate yet with more than one variable. So I have x's and u's, and the x's have to go. Right? We're substituting away the x's and introducing the u's. So the 2x and the dx have to go. Now, if you look at your differential equation, du dx equals 2x, with a slight bit of manipulation, put it in differential form, du equals 2x dx. We now have a substitution because 2x times dx is equivalent to du. So that tells me that I can replace the 2x dx with a du. And that's going to give me a u du. So what we did was we transformed our integral from something that we could not anti-differentiate to something we absolutely could. What is the antiderivative of u? U squared over 2, so I'll write 1/2 u squared. Missing just one little thing, plus c. All right. So that u, because what we want to do is reverse substitute at this point, because our answer should not be in terms of u. Our original integral is given in terms of x. I'm going to swap out the u for what it really is, x squared plus 1. All right. So this is just a little taste of the concept of u substitution, just something to get our feet wet. Tomorrow I'm not going to be here because I have to go on yet another conference. Another one. This one I'm actually interested in, so that's good news, I guess. But you're going to work on the textbook assignment for homework. I'm going to leave you a worksheet in class tomorrow. Extra practice on just simple integration. And then on Friday we'll continue. Well, I'll take questions on the textbook assignment, but then I'll also continue with this and give you another look at it. All right.